Okay, so this is the second part of the text classification. Last week we have covered text classification, but more on unsupervised approach, in which we learn the clustering technique. One is the k-means, and the other one is the hierarchical clustering. So this week we will look into some of the supervised learning. Supervised learning is where you have some label that you can take as a guidance in order for you to perform the text classification. Okay, so today we will look into two types of text classification. The first one is called decision tree, and the second one is called k nearest neighbor. Okay, so it make use of the knowledge of entropy. I believe you have learned what is entropy or information gain. Okay, so let's start this one. Okay, so last week we covered the clustering. This is unsupervised technique. So today we will cover the supervised learning. So it covers decision tree and also k-nearest neighbor. So the difference between unsupervised and supervised learning is that in supervised we need to have label. We need to have some guidance on how to classify the document. Okay, so we need the label. Okay, and also we need to find a model. Find a model means we need to train the model so that it can easily separate two or more than two number of classes. So given the training, so we want to create a model or we want to train a model that will be able to classify unseen document to the correct classes depending on the characteristic of the document that we have. Okay, so before we can use the model, first, of course, we need to train them. We need to provide them with the sample of document with the label. Okay, so once we train them, then we need to test what is the accuracy. So this is part of the data set that we have. Okay, so basically they have two phases here. Okay, so your document will be divided into two set of documents. Okay, the first one is called training set, and the second one is called test set. So we use the training set in order to train or learn the model. Okay, so this one could be any model. So in our example later on, we will use the decision tree and also the k nearest neighbor. So this is what we call the training phase. Okay, once we have the model trained, so we have this model, so they are ready to be tested. Okay, so we take the another part of the dataset. This is called test dataset. So we will apply the model that we learn and see how many of them that we manage to correctly classify according to the right type of classes. Okay, so we have two phases. One is training, second one is testing. So you only perform the testing once you have learned the model or once you have trained the model, then you can look at the accuracy. Okay, so this is the classification task. The main idea is that we need to know the background knowledge. What is the label of the document and how it looks like? So based on what they seen here, they come up with the model. Given the testing data, they will predict or they will classify the document into classes that are predefined. Okay. So for the training set, of course, we need to have a subset of training documents. So for example, if you have this data set, you need to divide them into two partition. So the percentage could be vary. So it could be 80%. This is 20%. So this is your training, and this is your testing. So maybe you also need to look at what if you split the data into 30, 70%. Okay. So in the modeling, in the training, you want to map the document into the classes. So if they are belong to that classes, then you will assign them to one, otherwise zero. Okay, so this is the whole idea here. But in order for you to look at this transition, you need to look at the training set function. Training set function. This is what you need to find. This is what you need to train the model for. Okay, so the training set function is used to fine tune the classifier in such a way that you can classify unseen document correctly. Okay, so this is your um, training set. Okay, so what happened now is that, okay, you have this document you have, and then you have predefined three number of classes here, C1, C2, and C3. And then you say, okay, for the training data set, I see, okay, this is the human specified classification. So you say, okay, based on the document here, this is you or several people, they say, okay, this document belong to class 1, or this document belong to class 2, and this belong to class 3. Okay, and then you will train the model or the classifier based on this information. So you need to have the label. This is the label, this is the document, and then you label each document which classes they belong to, and you feed this training set into the classifier in order to model the data set that you have in your training. Okay. Okay. In order for you to evaluate the classifier, we use the test set. So the test set is actually part of your data set. So normally this is a smaller version, 20% or 30%. Okay. So what you have is that you have the actual label. So what you need to do is you want to compare with the predicted label that you have come up with the new classifier. Okay. So what happens is that the classifier will assign the predicted classes to the document, and then later on you need to compare the classes assigned by the classifier or the classes predicted by the classifier with those specified by human specialist or with those actual label that given by the human specialist. Okay, so we are comparing between actual and predicted value. Okay. Okay, so what happened here is this is your test data set, okay, and then you pre-processing them, you select few feature selection, and this is your classifier that you have trained. Then you feed this input to the classifier. So the classifier will tell you which label they belong to. Okay, so this is the classes computed by the classifier, and then you need to compare with the actual classes that they have, and you look at the accuracy based on the number of document that has been correctly classified. So this is the evaluation that we have. Okay, so once you have trained and validated the classifier, then you can use them to classify new and unseen document. So the effectiveness of the classifier depends on the quality of training and also testing phase that you have for that particular uh, classification. Okay, so having to know there are two phases here, so we will look into this. So the first one is called decision tree, and the second one is called k nearest neighbor. Okay, so let's take a look at the first one. The first one is decision tree classifier. Okay, so based on the decision tree classifier, we are looking at how do we divide the document into group or classes that belong to no group or classes that has the same label. Okay, so we have a tree path that are used to classify document outside training set. So the path of the tree will be used as the rule to classify the document. Okay, so let's take a look at how the um, tree structure is being established. Okay, so for example, and this is an example of relational database in which we are looking at the class label here, which is the play here. Okay, so what we want to do is we want to predict the new data here, whether we should play or not play. So given the independent variable that we have here, so we will compute the entropy or the information gain. Okay, so depending on the information gain, then we will decide whether we play or not. Okay, so the tree could looks like this. Okay, so where they take the variable here, and then this is the individual values for each of the variable that we have. So for humidity, high or normal, or windy or not windy. Okay, and this is the label or the class. So this is the leaf. The leaf will tell you the type of classes that we have. So in the middle here, we have all the values corresponding to the attribute of our dataset. Okay. So so what happened here? The rule are saying that if the outlook is sunny, okay, if the outlook is sunny, and also the humidity is high, then that we will not play. So this is the rule that we are saying here, going to this direction. Okay, so the rule going here saying that if you have overcast, then um, you, you will play. Okay, so each path of the tree, starting from the root of the tree, going to the leaf of the tree, that is the individual rule that we can apply for the new instance or the new unseen data that we have. Okay. Okay. How does it work for text? Okay. So what happened is that we will um, create the tree. So the goal is to build a decision tree for attribute play. So we select one of the attribute that can be used to maximize the splitting between um, different classes. Okay, so we want to pick the uh, values that can effectively divide the document into the same class label. So this is the root. Okay, so we use the attribute value to split them into subset. Okay, for each subset of tuple, we select the second splitting attribute necessary, if necessary. If all the sample in that particular subset is all belong to one class, then we don't need to proceed. Okay. So for example, for the overcast, we will divide them based on three values, and then further from here we pick another one here again, and then we split them into two, and finally we get this. But the issue is, or the question that you want to ask is, how do you come up with these three? How do you choose the best route? Which route should be used? Okay, so the route means the starting point. Okay, so for us to have this, we need to select attribute that reduce average path length and also maximize the entropy that we have. Um, Actually, not maximize, minimize, because if we have entropy equal to zero, that means we have pure um, content, meaning all of them belong to the same class, one class. Okay, so this is where we say that at the end of the tree, we will have the class label. There'll be no more the value for the attribute, but at the end of the tree or the leaf of the tree, that one will be the label. Okay, that one will tell you what class that the document should be in. Okay, to define this classification of documents, so we should have this tree. So this tree is represented by the vertex or the node, the edge, and also the what we call the starting point, the root. Okay, so the root must be coming from one of the vertex or the node or the attribute. Okay, and also we are having, okay, the E is the edges that connect from the father node to the child node. Okay, and also um, okay, the I could be set of all internal node, and then the I complement will be set of all leaf node. So this is the last item in your tree. Okay, so when we want to do the classification of document, so we will have to pick certain roots here. Okay, so we say that if the value of the topic is chemistry, then we go here. If chemical, we go here, because chemical and also chemistry, they are two different separate entity, so we can split them. And then this one saying that if the document if the document consists chemistry and atom, then we say that they belong to the class label. So remember that the last component in your tree will be label or the class. Okay. So if the document has a term chemical, then they belong to the engineering. Very simple, straightforward. Okay, so for us to proceed with this, we need to define several keyword or several index term of a document collection. Okay, so the keyword will be used to direct the document which subclasses that they should go on. Also, at the end of the tree, we should have the label or the set of all classes, and P refer to set of logical predicates on the index term, which is the combination of term that we should define in order to classify a document. Okay, so for decision tree, we should have the vertex, the node, the edge connecting the father and also the child vertex. This is the root, and this is um, the link that will associate the internal node of the tree one or more index. Okay, so for this is for the internal, this is for the leaf, and E is um, P, a function that associates with each edge of the three logical predicates. So this is basically looking at the full predicate of your um, rules. So for example, if we have this is your root, and for us to go from the root, so basically we for us to go from this root to down here, this is your label. So we have the what we call it the keyword. So the function link e is referring to if you have a and also b and also c, then you are going to this label. Okay, so this is only for this one. This is only um, connecting from here to the leaf here. Okay, so that means if this is 1, this is 2, this is 3. So if you are in 3, if the value is C, then you go to label. But for this one is from 2 to 3, so let's suppose you have B, then you go to, so this one, no. So this one is basically, we are looking at the node. Oh, so if you are in the 2 and you go to 3 if you have B here. Okay, so this one is basically if you are in the 3 and you have C, then you go to L. No, basically here lah, 4. Okay, so that are all the 6 tuple that we require to have. So we need to define this. Okay, so the first step is to associate all document with the root. So meaning that all of them starting from the root. Okay, and then depending on the index term selected, we will separate them, and then we repeat until the tree is complete. So how do you know the tree is complete? That means you have all of them belong to one label only. Okay, so for example, over here we are looking at the keyword A, keyword B, and keyword C, and keyword H. So we split them into subset, and then further on we will look at the keyword D and then E to split them further at the second level. Okay, and once we are once there is no more splitting here, that means this is the class label. So similar to here, there is no more splitting. So the last entity or the last component that we have will be the class label. Okay. Okay. Now, how do we know that which keyword that we should use in order to split them? So we use the entropy. Okay. To select splitting term, we use IG or the entropy. Okay. When we select the term with high information gain, we tend to increase the number of branches at a given level and reduce number of document in each resultant subset. So meaning that we want to have a big group of document to be partitioned into a smaller subset which has similar label. Okay. Okay. So let's have a look at how do we use the information gain here. I think we have studied this one before. Okay. So uh, the info gain here depends on they use the entropy before and after. Okay. So we could measure the information gain by computing the entropy before, and then we subtract the entropy that we get after we split them. Okay, so this one referring to the probability of having that document in that particular class. Okay, so this is the same thing here. So this is log base 2. Okay, so what we want to do is we want to have the entropy to be 0, because if we have 0, meaning that we have pure label in each of the subset that we have. Let me give you one example here. Okay. So for example, if we have one group, this is the first group that consists of class 1, 0, meaning there is no class 1, but we only have class 2, 6 document here, and we look at the probability of having class 0, no, class 1 will be 0, and class 2 will be 1. So when we plug in the entropy here, looking at this formula, so this is the summation of all the entropy for all the classes that we have. So J here refer to number of classes. So in this example, we have two number of classes. So this is the first one. This is class number 1. This is class number 2. Okay. So when we compute this one, we will get 0, meaning that we have a pure collection of document in the subset. Okay. So in contrast, okay, let's suppose we have this set, which consists of 1 class 1 and 5 class 2. So the probability of having class C1 will be 1 over 6. The probability of having class 2 will be 5 over 6. So we apply the same formula here. So this is for the C1, and this is for the C2. Okay. So when we compute, this is the entropy that we have. So looking at this one, okay, so if we have similar label or a pure collection of document, then we have 0. But if we have only one of them, the value will be 0.65. And then we look at the last example here. We look at the entropy here. So the entropy is high when you have a mixture of two classes in one subset. Okay, so this is how you compute the entropy. Okay, so for us to compute the Ig is we need to compute the entropy before, and then we subtract the entropy after we do the splitting. Okay, so this is the formula. Okay, how do we do that? Okay, for example, let's suppose we have this 18 document here, and then 15 document belong to class 1, and then 3 document belong to class 2. And then we have chosen this keyword A, B, C, and then we have the splitting. So this is the first subset, second subset, third subset. Based on the example that we have previously, these are the entropy that we get, right? So to get the total overall entropy, basically we have to use this formula. So in which we are looking at the weightage here. Okay, so the weightage is referring to what percentage of the data that represented by that particular subset. Okay, so for example, this one, so the total will be 15. This is the initial one. Okay, this is the initial entropy. Okay, so initial entropy we have this, so we will have two. So one is 15 over 18. This is for class 1. And also we have 3 over 18. So this is for the class 2. So that's why this is for class 1 and this is for class 2. Okay, so we compute the entropy before we splitting will be 0.65. So this is 0.65. Okay, so once we split them into three subsets based on keyword A, B, C, so this one is the entropy for subset number 1. So this is the weightage because we have 6 out of 18. And then this is for the second one. We also have 6 over 18 because we have 6. The total is 16, right? Okay. So this is the last one. So when we compute, we get this. So when we subtract the entropy before and also after, we get this. So this is what we call the information gain. So the whole idea is that we want to minimize this because once we have minimized this, then we get this one larger. So the info gain is to maximize the value of the info gain by minimizing the entropy after you perform the splitting. Okay, so let's suppose we have this another example, but now we have CDE. Okay, but the distribution of the subset will be different now. Okay, so the entropy for this is 0 because we only have one label here, and the entropy for this is this one. Okay, so if we compute the IG here, this is the initial entropy before we splitting, and then look at this one. This one is the entropy for node number 1, and this is the weightage. Okay, 9 over 18. This is the entropy for second and third. So second and third we don't care. Okay, so for this one we get the IG to be 0.19. So what we can say here is that the keyword selection for CDF is more efficient in terms of dividing them into subsets that belong to the same label. Okay, so this is the process of what we call it the process of training. So when you get a new data set, then you just apply. So you just apply that if that document has C or D or E, F, then they will go to different subset. Okay. So this is your task. So sample of question that might be asked in the final exam. Okay. Any question? Any question from the floor? Can you type number 3 if you are okay or if you are still listening out there? Type number 3. Okay. So let's continue with the next one. Okay, before that, the problem that we may miss is that what if that document do not have the term that we have predefined in the decision tree? So we cannot classify them. Okay, and the solution is to delay the construction of the tree until new document is presented for classification. So that means we make sure that that particular new instance can be part of the um, what we call it the training phase. Okay. Okay. So now we go to the second one. So the second one is much easier because we use the distance as a measurement to classify them. So if they are nearest to class number one, then we decide the class will be class number one. If the distance is nearer to class number two, then we decide the class to be number two. Okay. So let's take a look at how do we perform KNN classifier. Okay, sometimes they call it lazy classifier because basically in this um, algorithm or in this approach, we do not train them. So instead, we just measure how far is the unseen data to the document that belong to different classes. Okay, so we will assign the class to that new document in which that label belong to the nearest class that the document belong to. So we need to measure. Okay. So the K here referring to the number of nearest neighbor. So depending on the majority of the K nearest neighbor, so we will assign the label to them. Okay. Okay. So for example, like this, the new document DJ here, if we have 4 nearest neighbor, the 3 of them belong to class B. So we decide the new document DJ belong to class B because we have 3 documents that is nearest to the new document we have here. Okay. So the similarity here will be depends on the similarity function here. Okay. So basically, they, they say that okay, what we want to do is we want to uh, find or compute the similarity between the new document here with the document that belong to the K nearest that we have. Okay, and then we look at okay, what is the training set function that we have here. So this is your what we call it the training data set, and this is the label of your training data set here. Okay, so we are saying that if that particular document belong to that particular class, so we will set to 1, otherwise 0. Okay, so our objective is to assign the class to the new document here, um, depending on the class that we achieve with the highest score. So which one has the majority of the um, classes nearer to that particular document that we have. Okay, so let's take a look at how do we define this one. So for example, okay, given document 1. Okay, so this is all the document that we have. This is all the document that we have. So this is a document ID. Okay, and this is the distance. Okay, so remember that you have studied the distance computation between how do you compute the distance between the query to the document that we have. We use the cosine function, right? So similar to this, we are looking at the keyword that we have for the new document and also the document that belong to certain class that we have. So this is the distance that we measure. We arrange them in sorted order, increasing order. Okay. So nearer to zero means they are more similar. Okay. So if we say one nearest neighbor, meaning that we assign to A. If two nearest neighbor, we assign to either A or B. Okay. So we pick lah. If three nearest neighbor, so that means we are assigning B because B is the majority votes here. So it goes up here. Okay. So it depends also on the K here, the value of K nearest neighbor. So it will tell you which label that we should assign them. Okay. Okay, the problem with the KNN performance classifier has to compute distance between document to be classified and all training document. That means if you have 10,000 or 100,000 of sample or document in your repository, that means you need to compute similar number of document that you have. If you have 10,000 or 100,000, you need to compute 100,000 times of distance between the new document with the document that you have in your database. Okay. And another issue is how to choose the best value for K. So K could be 1, 2, 3. So these are some of the issue that we have. So it could be part of your FYP if you decide to do this. Okay. Okay. So we are at the end of the slide already. Okay. Okay. Any question?